In this video, I will show how to use the integral test to determine whether the given series is convergent or divergent. So before we use the integral test, we have to verify that all the conditions are satisfied. That means we have to consider a corresponding function, which is obtained by replacing n with x, and make sure of the following three things. So f of x must be continuous in its domain. So in this case, the domain is from 2 to infinity, and as we can tell, for no values between 2 and infinity, the denominator is equal to 0. So function is continuous. 2, function must be positive, and that's clearly the case because ln of all values greater than 1 is positive, and n is also always positive. And 3, f of x must be decreasing. How do we make sure that the function is decreasing? Well, the easiest way is to find the derivative of the function. So in this case, the derivative of the function will be, we're going to use the chain rule, so it's the derivative of the reciprocal times the derivative of the function that's inside of the reciprocal. So derivative of x ln x is derivative of x times ln x plus derivative of x times derivative of ln x times x, which is 1. And what do we see here? When x is greater than 2, what's in parentheses is positive. This part is positive, but because of this negative, the whole thing is negative. Therefore, the function is negative, decreasing on the domain from 2 to infinity. So this is what it takes for us to just make sure that integral test is applicable. And once we made sure that the test is applicable, we are going to make this claim. The given series behaves in exactly the same way as the improper integral of this function on the interval from 2 to infinity. And now all is left is to find this integral. Is this integral convergent or divergent? Let's find out. We're going to do a substitution here. So t equals ln x. Dt then is equal to 1 over x dx, and the limits of integration then will be, the new limits of integration will be from ln of 2 to infinity. So we have integral from ln of 2 to infinity of 1 over t dt, which is ln of t, which we evaluate from ln of 2 to infinity, but we cannot use infinity in the limit, so we set it up as the limit as b goes to infinity. Now this will be same as finding the limit as b goes to infinity of ln b minus ln 2, and ln b as b goes to infinity is infinity, therefore the entire limit is infinity. Therefore this integral diverges, and we make the conclusion that the given series diverges, and the reason is by the integral test.